Alright, so this is going to be the quick mini lesson over the real number system. We're going to go over everything we went over in the past 2 days just in this few minutes of a lesson. We do have the real number system, so I'm going to go ahead and start with creating our chart for the definitions. For the words of the real number system, we have a few of them. We have real number, we have natural and counting, which are one and the same. We have whole, we have integers, we have rational, and then we have irrational. In our next spot right here, we're going to start talking about the definitions. So talking about our first definition, we have the real numbers. Remember, the real numbers is the umbrella or the set before we get into all the subsets. So a real number are all the subsets of rational and irrational numbers. We will talk about rational and irrational in just a second. Next, we have counting and natural numbers. They are one and the same. They are all the positive counting numbers, starting at 1. For example, 1, 2, 3, 4, going on all the way to infinity. As long as you can count them, 1, 2, 3, 4, so on and so forth, that is an example of a counting and natural number. A non-example is 1.5, 3 3/4, 0. Start off counting with your hands. 1, 2, 3, 4, 5. You cannot count decimals or fractions on your hand. Next, we have whole numbers. Whole numbers are all the positive counting numbers, including 0. So if you notice our example, I still have the counting numbers here, 1, 2, 3, and so on and so forth, but I've included 0. So it's 0, 1, 2, 3, and it continues on forever. A non-example is 0.5. That's half of a number. We can't count half of a finger. So 0.5, 1.5, 2/3. Those are considered non-examples. And those are just some of them, not all of them. Next, we have integers. An integer are all positive and negative whole numbers. Okay? So again, positive and negative, think about money. We have -3, -2, -1, 0, 1, 2. All of those are positive and negative numbers. But then again, remember that they continue on forever in both direction on a number line. A non-example, 2/3, -2/3, the square root of 2. Those are just some examples. Then we get into rational numbers. A rational number is a fraction where a over b and b cannot be 0. Up here, a is your numerator, b is your denominator, and it will terminate. For instance, an example. I have some quick examples of a fraction here. 2/4 can simplify to 1/2. And if I wanted to convert it into the decimal, it'd be 0.5. It terminates. 1/2 is actually 2/10, okay, or 20 cents, which terminates. A non-example would be 1/3, which is 0.333333, and it goes on forever. That is a non-example because it continues on. 2/3, again, another one that continues on forever. Pi, 3.14, I don't know the rest of the numbers, but it goes on forever. These are just some examples. Which brings us to our last vocabulary word. Irrational are the crazy numbers, the non-terminating ones. So these are actually the examples of the non-examples. So 1/9 is non-terminating, 1/3 is non-terminating, pi is non-terminating. A non-example would be all of these examples because they are not part of this same category. So whole numbers, we could say whole numbers, we could say natural, we can say integers, we could say rational. None of those are considered irrational numbers. All right, next we're going to go over some diagram examples because you are going to be tested over diagrams. Our first diagram is going to be this one here. Okay, this is our first one. Remember, on the outside, you have the umbrella of real numbers. Okay. Then inside of real numbers, you have both irrational and rational. Both of these are part of real numbers. Then you have the subsets of rational numbers. Well, integers are rational. Whole numbers are integers and rational. Natural counting numbers are whole, integers, and rational. However, irrational are by themselves. They are not one and the same. They are part of a different group. Example number 2. We have another image. This huge box represents all of the real numbers. All of the real numbers include irrational numbers. It includes rational numbers, integers, whole numbers, counting natural numbers. Everything falls under the umbrella of real numbers. But, again, rational includes integers, whole, and counting natural numbers. But then we have to remember, counting or natural numbers are not whole numbers because counting does not include 0. Whole numbers are not integers because integers include negative numbers. And rational numbers are not integers because rational numbers are the fractions. Our third example. You have another diagram. You have real numbers. Again, the umbrella, it covers all of these numbers here. Irrational numbers, which are by themselves because those are totally different than these here. Remember, irrational numbers are those crazy numbers that never terminate. Rational numbers are fractions and they terminate. You have integers, whole, and counting natural numbers. If you need to, what you can do, go back to this first example and fill in some examples so that way you can remember. Because I can guarantee you, because we did this definitions over here, doesn't necessarily mean you understand. Put some of those examples inside of these diagrams. That way you know. Alright, so with that being said, we went over the definitions. We went over some pictorial examples. But now we're going to practice everything that we just learned. So here, these are just regular true or false questions, but in order to answer them as true and false, you have to know this. So a rational number cannot be written as a fraction. Well, if we remember, they're saying cannot, meaning it's not possible. If you remember, a rational number is a fraction where a over b, but b can't be 0. So a rational number cannot be written as a fraction. False, because it can. It's supposed to be a fraction. A whole number is also a rational number. We'll go back to that diagram. Okay? If you look here, a whole number is a rational number. Is whole number inside rational? Yes, that is true. The smallest subset of rational numbers is integers. Well, let's go back to our diagram. It's saying again, the smallest subset, meaning the one on the innermost of rational numbers. Here it says natural or counting, but here they're saying is integers. This right here is false. To make it true, it would have to be natural or counting is the smallest. Okay. Our next one, all irrational numbers cannot be written as a fraction. True or false? Well, if we think back to some of my examples, all irrational numbers cannot be written as a fraction. Well, if you look at over here, rational numbers are here. And if you remember what rational numbers are, they're fractions. So an example, all irrational numbers cannot be written as a fraction, is false. So I did say it was false, and remember here, all, which is not true. Some of them are decimals. Pi is a decimal. An example of an irrational number is a perfect square. A perfect square is going to be like the square root of 4 equals 2. 2 squared is 4. These are terminating, meaning it would not meet the definition of irrational because these are not crazy. These terminate. Irrational are crazy, non-terminating. So this is false. -5 is an example of a whole number. If you remember, whole numbers, if you recall, are all positive counting numbers. Well, yeah, this would be a counting number if this was not negative. So this is false. 22 pi is an example of an irrational number. Well, if you recall, pi is irrational. 22 pi is irrational. This is true. Now, the part where I need you guys to focus even more. Which of the following are natural numbers? Remember, natural is the same thing as counting. So 1, 2, 3, 4, 5. This is the only one because this has a negative. Natural and counting numbers do not include 0. 5 is counting. This is the square root of 10, which is not. Number 9. Which of the following is a whole number? And again, whole is including 0 and all the counting numbers. So 0, 1, 2, 3, 4, and so on. This is a square root, not possible. This is a decimal, not possible. C is 9, maybe. And then D is not possible because that's negative. So yes, the answer was 9. Here, this is the square root of 2, an irrational number. Yes or no? Yes, it is. To determine that, you would use your calculator. Now down here, I'm not worried about number 11. I'm going to ignore that. Number 12. Which of the following best describes 8.22222? And this right here means that is repeating. It goes on forever. So looking at A, if you remember, rational is a fraction. Fractions can be converted into decimals. However, they terminate. This here means non-terminating. So that can't be it. Irrational means it goes on forever. That is it. This is not natural and this is not whole. Okay. So I've wrapped up our lesson. This is going over real numbers. I have condensed 2 hours into 15 minutes. Pause it, rewind it, do what you need to do. I will post your class homework in just a second.